Welcome back. Algebra 1A. This is the last lesson for week 6. Today we're just going to review factoring, all of its different versions, starting from greatest common factor to factoring a trinomial to difference of squares and also solving all of those things. So this should be pretty quick. Okay. So first things first, let's practice reviewing some greatest common factor here. So anytime you're asked to factor any expression, you should follow these steps. First thing you should always look for is a greatest common factor. And if you have one, you should factor it out immediately. Okay? After you look at that, then you need to decide, does it have 2 terms or does it have 3 terms? If it has 2 terms, there's a pretty good chance it's a difference of squares. And if it's 3 terms, you are just going to do what we did before. And I'm going to call it something different today. I'm going to kind of give it a nickname and give you another little visual organizer for your thoughts here. But if it's 3 terms, you're going to do what we did when we factored a trinomial. Okay? Factor trinomial. Okay. So example number 1, we're going to look at just a binomial, 4r squared minus 12r. Always check for that first greatest common factor. Is there one there? There is a GCF between 4r squared and 12r. So we are going to go ahead and factor that GCF out. The GCF will then be 4r, so I'm going to divide both terms by 4r. So 4r is my GCF. And when I divide the first term by 4r, I get r. Negative 12 divided by 4 is negative 3. R divided by r is just 1. So there you go. Notice I did not set this equal to 0. I didn't put equal 0 at the end, and I'm not solving this. It's not asking me to solve. It is specifically asking to factor. Do not solve if it doesn't ask you to solve, okay? Answer the question that's being asked. For number 2, we have negative 63 u to the third v to the third minus 81 u squared. So for this one, since our leading coefficient or the number in the front is a negative number, we're going to factor out a negative number. If you remember this from the GCF lesson, you might not, and that's okay. But we are going to go ahead and factor that out. So if you look at look at 63 and 81, okay? The greatest common factor between the numbers 63 and 81 is a 9. But again, because we have this leading negative in front, we're going to divide both of these not by just 9, but a negative 9. Okay, and then let's look at our variables here. We have a u to the third, v to the third, and in the second term we have a u squared. So that means they have a u squared in common. They do not have any v's in common. If this stuff is a little confusing to you, you might want to go back and look at the GCF video and go back and revisit that stuff, okay? So we're going to divide each one of these terms by negative 9u squared. Okay, and then what is left over, we're going to divide these out. Negative 63 divided by 9 is going to be 7. So it's going to be a positive 7. U to the third divided by u squared is u. And then the v to the third kind of just sticks around. It doesn't divide. Nothing divides out there. And then for your second term, I do have a negative divided by a negative, which will give you a positive quotient. 81 divided by 9 is 9. U squared divided by u squared divides to 1, so that cancels out. So that means that is your factorization, okay? Those are your greatest common factors for those. In number 3, we don't have a greatest common factor. Look at all of your terms. None of the terms have something that they can divide by that they all share, okay? 15 and 54 are both divisible by 3, but v squared is not. So there is no GCF for this, okay? So I'm going to put a little star here. There is no GCF, okay? So we do, when we do have trinomials that we need to factor, if you remember from learning about this, we talked about what two numbers will multiply to give me 54 that add up to give me 15. Because what we're doing is we are undoing the FOIL process. There is a little visual representation of this that I like to use, and it's called the diamond. Okay, and it's actually a cross. So do like a diamond cross here. It's a diamond because if you fill this in, it kind of looks like the 4 diamonds thing from Thon, but I just do the X in the middle. So I'm looking for two numbers, and you see how these guys are in the expression. I'm going to put the 15 on the left and the 54 on the right. Okay, so what two numbers add up to give me 15 but multiply to give me 54? Okay, the two numbers are going to be 9 and 6. Those two numbers add up to give me 15 but multiply to give me 54. So as we write our factorization, okay, we have v squared is our first product. So that's going to be v multiplied by another v. Then we have a positive 9 and a positive 6. So plus 9 plus 6. And those will be our factors right there. So if you FOIL this, quote, FOIL back together to check your answer. So you're going to FOIL first products. V multiplied by V is V squared. My outer products, V multiplied by 6 is 6V. My inner products, 9 times V is plus 9V. And then my last, 9 multiplied by 6 is 54. Add those up in the middle for your like terms. V squared plus 15V plus 54. Whoops, that is not a 4, that's a V. 54, check, that's correct. We got it right. Okay, so I like this diamond method. It's just one of those things that kind of gives you a visual. It kind of organizes what you're trying to do in your brain. So I would really like to see you writing that down when you're trying to work on these. You can either do the diamond, or you could just, look, you can show me your factor pairs for 54, 1 and 54, 2 and 27, 3 and 18, blah, blah, blah. Either way, I would like to see some kind of work to document your process. Okay. For number 4, we have x squared plus 14x plus 48. Again, we do not have a greatest common factor. Even though it looks like we could divide everything by 2, we cannot, because x squared does not have a factor of 2. You can't divide x squared by 2 and not have a fraction. Okay, so that means we have 3 terms. So now we're going to look for, you could do your diamond, which is what I would like for you to start using. Okay, we have 2 numbers that add up to a positive 14, and they're going to multiply to give me a positive 48. Okay, so again, this is your sum and this is your product. So what 2 numbers multiply to give me a 48 but add to give me a 14? If you don't know this off the top of your head, that's totally fine. Just do some of your factor pairs. Write out 48 and do, your 1 and 48, 2 and 24, 3 and 16, blah, 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 and so on and so forth. You'll eventually get to 6 and 8. 6 times 8 is 48, but 6 plus 8 is going to give me 14. So that's your pair. Okay, so we need a positive 6 and we need a positive 8. So that way they sum to 14 and they multiply, or their product is 48. Okay, so that's your factor pair, a positive 6 and a positive 8. So we have x squared, x squared plus 14x plus 48 becomes x plus 6 multiplied by x plus 8. Please remember that your x squared doesn't disappear. It's still here. Okay, it's just written in a little bit of a different way. So for example, if you write 10 as 5 multiplied by 2, that doesn't mean the 10 is gone anywhere. The 10 is still there. It's just written in a different way. We're taking a $1 bill and turning it into 4 quarters. It still has the same value. It just looks a little bit different. Okay, the x squared term, it's there. It's in the FOIL part. It's in the multiplication. Okay. Next, x squared minus 196. Okay, so first things first, is there a GCF? There is not. Nope, I can't divide both of those items by anything because x squared is just x squared. It's not divisible by any integer. Okay, so that's a flop. So how many terms do I have? In this case, I have 2 terms. Is it a difference of squares? And in this case, it actually is. 196, the square root of 196 is 14. Okay, so that means x squared is going to be x squared minus 196 is 14 squared. Okay, so because it's a difference of squares, it's going to be x plus 14, x minus 14. And you can write those in any way you want. You can put x minus 14 first. It doesn't make a difference. Okay. Remember, differences of squares are set up in such a way that when you do the FOIL process, when you multiply your 2 binomials back together, your outer and inner products are going to add up to 0. That's why there's only 2 terms in this expression. You have your first product and your last product, and your O and your I from your inner and outer products cancel out. They add up to nothing. Okay. Number 6. First things first, is there a GCF? Greatest common factor. There is not. You could divide everything by 1, but you get right back where you started. So you're not getting anywhere by dividing by 1. Okay. And is this, how many terms do we have? We have 2 terms again. So is this a difference of squares? In this case, again, it is. 121x squared is the same thing as 11x multiplied by itself, which is 11x, the whole thing squared. And then 1 is 1 squared. So by our definition of a difference of squares, we will have 11x plus 1 and 11x, whoops, that's not an 11, 11x minus 1. Okay, cool. So we're going to keep on practicing this stuff. Now we're going to solve. So on your homework, yours already has the equal 0 on it, I believe. For some reason, mine decided not to show up, which is awesome. But that's okay. I just wrote them in. It's still the same questions. I just, the equal 0 for some reason is not present. Okay, so we are going to go ahead and we're going to solve by factoring first. So make sure you're following the directions on these. Okay, don't skip steps. And I want you to show me every single tiny little ounce of work that you have. Okay, so for number 7, I have 54 minus 78n equals 0. So solve each equation by factoring first. So let's look at 54 and 78. What is the greatest common factor between 54 and 78? It might take you a little while to figure it out, but the GCF equals 6. So for this one, it's a 6. We're going to factor that out first. So first things first, is there a GCF? The answer is yes. Let's factor that out before we do anything else. Okay, so we got a 6. So that means I am dividing, actually I'm going to erase this and give myself some more room. It is 6, so I'm going to divide both of these by 6. Okay, so 54 divided by 6 is going to give me 9. So I get 6 in the front, and then 9 minus 78 divided by 6 is 13. So it's going to be minus 13n equals 0. Okay, so now you have your factors. You have 6 and 9 minus 13n. Both of those multiply together to equal 0. So now you're going to do that thing called the zero product property that tells us that if you have 2 numbers that multiply together to form a product of 0, one of those numbers has to be 0. That's the only way. Okay, so if we take each of our factors and set them equal to 0, so 9 minus 13n equals 0. You'll see that 6 equals 0 doesn't make sense. That's just false. Okay, there's no variable to solve for. So in the other factor, so there's really going to be only one answer for this one, okay? We're going to subtract 9 on both sides. Make sure you are using your operations properly, okay? Negative 13n is equal to negative 9. Divide both sides by negative 13. So don't skip steps. I want you to write all of this stuff down, please. Okay, and then we're going to get n is equal to positive 9 over 13, because a negative divided by a negative gives you a positive quotient. Okay, just take your time, work through these things, and it'll be good. Okay, just take your time. Number 8, we're going to do the same thing. So we have, is there a GCF? You're going to go down the same set of questions for every single problem that you do. Is there a GCF? The answer is yes. In this case, we do have a GCF. It's not, the numbers aren't the greatest common factor, but the b's, you can factor out a b. And to be honest, it's actually b to the third. Okay, so if our GCF is b to the third, we are going to divide both terms in this situation by b to the third. Don't forget to leave that out front. 5 divided by, that's going to be a 1, is going to be 5. B to the 10th divided by b to the third. Remember, when you divide bases, you subtract your exponents. So that's going to leave you with a b to the 5th. So 5b to the 5th plus 9b to the third divided by 1b to the third is a plus 1. I'm sorry, plus a 9. Just kidding. 9 divided by 1 is 9. B to the third divided by b to the third is 1. So that's where the 1 was coming from. Okay, so equals 0. Then we're going to set, we have our zero product property. So step 2, zero product property. So we have b to the third is equal to 0. And then we also have 5b to the 5th plus 9 is equal to 0. Okay, so what number multiplied by itself 3 times is 0? That's just 0. Okay, 1 times 1 times 1 is 1. The only number multiplied by itself 3 times in a row to give you a zero product is 0. Then we're going to solve this other one here. So the first thing I want to do is subtract 9. Okay, so this is going to be a little crazy for your answer. We're just going to do this. So 5b to the 5th is equal to negative 9. Divide both sides by 5. And I'm going to get b to the 5th is equal to negative 9 fifths. And I just want you to leave that like that. This question was put on here in error, but that's okay. It's worth seeing the process. You'll learn later on that you're going to be taking the 5th root on both sides, but don't really worry about that so much. So this one's a kind of a sneaky one. I don't even know how it ended up on this worksheet, but whatevs. That's okay. We'll just leave it like that. The process is worth seeing. Okay. Next. Number 9. We have a squared plus 20a plus 96. Okay, so what we're going to do is there a GCF? Look for a greatest common factor. In this case, there is not a GCF. So number 1, GCF. No, there isn't one. We have 3 terms. So I'm going to do my little diamond thing and look for 2 numbers that multiply to give me 20, that add to give me 90, positive 96. And if you go through your factor pairs, and by factor pairs, I mean like look at all the numbers that multiply to give me 20, 3 doesn't work, but 4 and 5, blah, 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 so on and so forth. You get a positive 12 and positive 8. They multiply to give you 96, but add to give you 20. So when you factor this, you're going to have a plus 12 multiplied by a plus 8. Okay, got that. Now let's take a look for our zero product property. Set each factor equal to 0. A plus 12 is equal to 0. A plus 8 is equal to 0. Please don't take shortcuts here. subtract 12 on both sides for this one. I'm going to get a equals negative 12. And then in my second factor, I'm going to subtract 8 on both sides. So I get a equals negative 8. Okay, and there are your two solutions for number 9. And last, let's take a look at number 10. Well, almost last, next to last. We're going to take a look at number 10. Oh, just kidding. We still have more. Forgot about those. Okay, so 1, GCF is a no. There is no greatest common factor. You cannot divide everything by 3. So there's no greatest common factor. So that means we need to look at how many terms there are. There are 3. So I'm going to make my little diamond here and say, ooh, I'm going to have a sum of a positive 3, and I'm going to have a product of a negative 28. Okay, so what two numbers add up to give you positive 3, but multiply to give you negative 28? Think a little bit through this, and it's going to give you, the two numbers are going to be a positive 7 and a negative 4. Those are going to be your two factors. So x plus 7 is your first factor. X minus 4 is your second factor. So we are taking this $1 bill right here, and we're making it 50 cents, or we're making it 4 quarters in terms of changing its appearance, but not changing its value. They have the equivalent value. They just look different. Okay. So then we're going to take, once we have our two factors, we're going to take each one. We're going to use our zero product property. We're going to set each one equal to 0. So x plus 7 is equal to 0, and x minus 4 is equal to 0. Show your work, solve this for x. So I'm going to subtract 7. X equals negative 7 for the first one. Add 4 on both sides for your second factor to get x equals 4. And there are your two solutions for number 10. Okay. A couple more here. Let's just go through these. We have 49n squared minus 256 equals 0. So first things first, I mean, you guys should be tired of hearing this at this point. So number 1, GCF, is there one? No, there is not. Okay, I mean, it's 1, but that doesn't help us. How many terms do we have? We have 2 terms. So is it a difference of squares? And in fact, it is. 49n squared is 7n multiplied by itself, so 7n squared. And then 256 is 16 squared. Okay, so now I have my format, so 7n plus 16 and 7n minus 16. We have our format for our difference of squares, and we can just kind of plug in what we need here. And we're going to set each one of these equal to 0. 7n plus 16 is equal to 0, and 7n minus 16 is equal to 0. Solve each. Don't skip steps. Show me everything. Subtract 16 on both sides. So 7n is equal to negative 16. Divide on both sides by 7. Okay, so that gives me n is equal to negative 16 over 7. In the other factor, I'm going to add 16 to both sides to get 7n equals 16. Divide both sides by 7. N is equal to 16 over 7. Okay, got 2 more to do. Okay, so take a look at number 12 and look and see if you can find a greatest common factor. In number 12, you have 25n squared minus 196 equals 0. So I'm going to take a look at this guy. Is there a GCF? There is not. 25 is only divisible by 1, 5, and 25, and 196 is only really divisible by 1 in common. So that's not super helpful. We're right back where we started. So nope, sorry. How many terms do we have? We have 2 terms. So then we need to look and see, is this a difference of squares? And it is. 25n squared is going to be 5n squared, 5n multiplied by itself. And then 196 is actually 14 squared. Okay. So now we have our format for our difference of squares factorization. So this is going to be 5n plus 14 and 5n minus 14. So set that equal to 0. And now we are into zero product property area here. So set each factor equal to 0 equals 0. And then 5n minus 14 equals 0. So show your work. Subtract 14 on both sides. So I got 5n is equal to negative 14. Divide both sides by 5. And I get n equals negative 14 over 5 for one of my solutions. For the other one, add 14 on both sides. I get 5n is equal to positive 14. Divide both sides by 5. And I get n is equal to positive 14 fifths. Or 14 fifteenths. I keep saying fifths. No, wait, it's 14 fifths. Oh, Lord. There we go, 14 fifths. Got it. Whew. Okay. Last example, promise. Describe and correct the error in factoring and solving the equation below. Okay, so what's the problem in this one? Take a look at it. What's the issue? So let's see. Is there a GCF? Okay, so there's no GCF. Okay, they didn't factor that out, so that's good. So far, so good. Is it a difference of squares? Because we have two terms. So the answer to that is actually yes. Because 9x squared is going to be 3x squared minus 100 is 10 squared. There's a problem. There it is. The square root of 100 is not 50. Okay, whenever you are looking for the two numbers that multiply to give you 100, make sure that you are not dividing 100 by 2, because 50 times 2 is 100, but 50 times 50 is not 100, okay? Remember, this is a multiplication thing. So this is equal to 0, so what is the problem? So the error is that 50, positive 50, multiplied by negative 50 is not negative 100 as it states right here. So that's the problem. So let's go ahead and fix this. So we're going to factor difference of squares. 3x plus 10 and multiplied by 3x minus 10 equals 0. Set each one of those factors equal to 0. So 3x plus 10 is equal to 0. 3x minus 10 is equal to 0. So take your time, show all of your work. 3x is equal to negative 10, divide by 3 on both sides. X is equal to negative 10 thirds. Here I'm going to add 10 on both sides. 3x is equal to 10, divide everything by 3, and x is equal to positive 10 thirds. Okay, so that's a multiple part answer. You have your solutions, but you also have to indicate what the error was. Okay, that's it. Week 6 has come to a close. You are donezo with this week. I hope you all have had a good week. I hope today is going well. I hope you have a great weekend. And if you need me, reach out any way possible. I don't care if it's Schoology message, Remind message, email, whatever. Just let me know you need me if you need me. Otherwise, take care, stay safe, stay healthy, and wash your hands. And wear your mask. Goodbye.